Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on January 5th, 2026, just yesterday. It presents K-EXAONE, a new multilingual foundation model that leverages a sparse mixture of experts architecture to achieve frontier-level performance while keeping inference costs low. The paper is titled K-EXAONE Technical Report, and as we'll see later, the results on reasoning and agentic tasks are particularly impressive given the model's efficient design. And for those interested in the implementation, the authors have shared their code on GitHub. On Hugging Face, the 236 billion parameter model with 23 billion active parameters is ready for download. You will also find helpful usage examples to get you started now. So Figure 1 summarizes the model's comprehensive evaluation across 8 key categories, ranging from world knowledge to safety. The dark purple bars represent K-EXAONE, which is compared here against other reasoning models like Qwen 3 and DeepSeek v32. In the top row, the results on the AIME 2025 math benchmark are particularly strong, where the model scores 92.8. Then, looking at the bottom right, it also leads on the KGC safety benchmark with a 96% score, showcasing its robust design. Now, Figure 2 breaks down the internal architecture that drives those results. On the left, the main block processes the input using a stack that alternates between global attention and sliding window attention, a hybrid design that keeps memory usage low for long sequences. The center inset details the sparse mixture of experts layer. Here, for every token, a router activates just 9 experts, 1 shared expert, and the top 8 routed experts from a pool of 128. Finally, on the right, the multi-token prediction block predicts the next future token during training, which creates a faster, self-drafting capability during inference. Alright, Table 1 puts concrete numbers to that design. The main block section reveals a 48-layer depth, combining 36 layers of sliding window attention with 12 layers of global attention. Crucially, the experts row confirms the efficiency we mentioned, showing that while the model holds 236 billion total parameters, only 23 billion are activated per token. Finally, the bottom rows detail the multi-token prediction block, which adds a lightweight 500 million parameters to support the auxiliary training objective. Well, Figure 3 highlights a major upgrade in tokenizer efficiency. The chart measures bytes per token, where higher values mean the model packs more text into each token. The purple bars show K-EXAONE outperforming the previous version, thanks to a larger vocabulary and super BPE, which merges common sequences into single tokens. The largest gain is in the multilingual category, jumping nearly 50%. Korean and code inputs also improve, rising by 29 and 27% respectively. So, Table 3 presents the comprehensive evaluation for K-EXAONE in reasoning mode, comparing it against heavyweights like Qwen 3 and DeepSeek v32. In the math section, the model achieves an impressive 92.8 on the AIME 2025 benchmark, slightly outperforming GPTOS 120B. Moving down to coding and agentic coding, it scores 80.7 on Live Code Bench v6, confirming its strength in programming tasks. Finally, the Korean section highlights its specialized advantage, where it leads on the Cobalt benchmark with a score of 61.8. While Table 3 focused on capability, Table 9 evaluates how safe those responses are using the KGC safety benchmark. This evaluation spans 4 critical dimensions, which are listed in the columns, ranging from universal human values to Korean sensitivity. Looking at the bottom row, K-EXAONE demonstrates superior alignment across the board. It achieves the highest overall score of 96.1, effectively balancing strong reasoning with strict safety standards. Notably, it excels in Korean sensitivity with a score of 94.3, significantly outperforming global models like DeepSeek and Qwen. Wrapping up, 2 takeaways stand out. K-EXAONE proves that sparse mixture of experts architectures can deliver frontier-level reasoning and coding skills without astronomical inference costs. It also highlights the value of sovereign AI, demonstrating that models tailored to specific linguistic and cultural contexts, like Korean safety standards, can still compete globally on general tasks. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.